group assignment. And then for the, they come up with a report. So your appendix is just your previous output. So you just summarize your result and put in the main text, in the test. Then for your presentation, right? So for your group presentation, either you want to appear in the videos, or you just contribute your voice, or just contribute your face. So it depends on how you design. Because nowadays, I think there's no problem or no issue for this generation Z, right, to correct your video. So there are so many free things online, so you can help you to correct your video. So you can update the things in the spectrum. So okay, so now start back. Have you gone through the journal articles that are updated in the spectrum or not yet? Okay, right? So for the week 1 to the up to here, there are a lot of articles for you to refer, right? So now I did not upload the original article like the Petroni, like the Dow or the Johansson's like the papers, original papers. I just upload the apply papers. So now let's just go through the another test, which is called Fisher test. So as we apply in the time series, we have the ones. What we say the ones. Let me go through the. So this one is a combined individual test. It's proposed by this Mandala and Wu, 999. So this one is called Fisher, or we call it Johansson. So this Fisher, right, is a combined test that gives a result for the individual. So and then Mandala and Wu use the Fisher result to propose the approach to test for the correlation in the panel data. So it's based on Johansson, but they use the Fisher ideas, right? Because so they're based on Johansson, but they use the Fisher ideas to test for the correlation, to combine the test from the individual cross section. So by using the Johansson approach. So this is how this works. So under the same personnel, no correlation as personnel. So the Mandala and Wu is just easy. They just use the Fisher result. The Fisher result, which get the p-values, right? So based on the mechanism and this one measure p-value for the Johansson, and then they compute. Then they just keep like the recompute the result from. There are two results, right? Two statistics from the Johansson. One is the trace, the other one is the eigenvalues. So this Mandala and Wu is the Fisher and also the Johansson result. Then they this Mandala and Wu use these two and then calculate the test statistic. So this is an example which I screenshot from this Crystal Forest 2004. So this is how this is just an individual, right? Yeah, this is an individual Johansson correlation test. Then you see, first the reporter, you can see how the previous paper report the result. So even though just give it the time series, right? So they first report this individual Johansson correlation test, just an eigen statistic. So they have so you can see they have one vectors. There are one vectors, so they reject the R equals to 0. Then for all the country under investigation, so there are only one correlated vectors. They also perform this unary test. Then they proceed to the unary test to deal with the panel analysis. So they report the IPS and also the Mandala and Wu, the MB Mandala and Wu chi-square for the unary for each variable. So for each variable. So even though, for example, you are running the panel, right, you still can report the individual result. This is for your group assignment direction. So even though you during the time series, right? So for example, you just focus on, for example, like Malaysia case, then you report the correlation test for Malaysia. Let's say you have a several country, then you come up with a time series, then you can proceed with the panel unary. Then report whether they're either or not, right? So it's very sure, it's very obvious that all the variables under investigation actually is the first difference only stationary. Then you was because now you already go through the unary class, right? So you will start to think why the author did not proceed with the Hartley test, right? Hartley that use the stationary as a noun, right? So for your case, you can apply the Hartley test. You also can apply the other test to complement the result. But these two shows in this paper shows that these two statistics actually means that these two sets statistics actually shows that the variable is I1. Because it's first difference only stationary, right? First difference only stationary, so it's I1 variables. So I1 variables, what it's going to do? Once you found I1, so you cannot rely on this conventional, what we said, estimation, right? Like the Pulley square or the random effect, fixed effect, because your result going to spurious. So in order to deal with I1 variable, if you want to bring up this spurious regression issue, then you will proceed to the panel conjugation test. Because of I1, I'm sure you're going to proceed with conjugation. Like the three statistics we introduced you today, like the patronic, to see whether there is a conjugation in the long run or not. So you can use the patronic, but the paper I show you here did not report the patronic. They report the Fisher conjugation test. Why? Because you want to complement with the individual test, right? There's no right or wrong, because you said, why not this fellow did not provide the patronic? Because they want to highlight the system conjugation test. So they report the Fisher conjugation test. And then together with another two more test statistics, which we did not cover in the class, you can take a look further at the discussion for this additional two conjugation tests. Because today we just cover the patronic, Fisher, and also the Gauss conjugation. So these are the things. But Fisher, but what we say, the Gauss is seldom used in the research as compared to the patronic and the Fisher. So patronic is quite widely used, and also the Fisher conjugation test. So again, this Fisher concentration test, the result actually consistent with the individual conjugation test, for instance, tag conjugation, also shows that one conjugating vectors. Also shows one conjugating vectors, so complement the result in the time series analysis, because as compared to the critical value here at 1%. So only one conjugating vectors. Also the Levin, these two statistics also shows that there's conjugation in the long run. Okay, so this is just a result from the Crystal Forest 2004. So now, actually, this Fisher has a different what is said test equation. Different test equation like the Johansson have a different test equation. Either you have no trait in the data or linear trait in the data, as well as a quadratic trait in the data. So as normal, just not say normal like the widely use option, not say optional, the test equation is number 3. So they assume that intercept no trait in the corrected means that the project equation and also the one. So case number 3. That's why you see by default also is number 3 here. So at least you have a certain reason for you to choose other option. So I don't think it's very wise for us to test all the test equation, right? Because you should have what we say the valid reason why you choose, for example, quadratic trait in the data. At least you have some theory to support you. Then you choose the option number 5. But by default in the reviews also show us that number 3 here. So we want to test by using the whether we have a conjugating with the intercept or not. Intercept in the Y and also our analysis. And then the lag intervals, lag specification for the different heterogeneous is 1 here. 1 here. So actually you have option, cannot say option right, for us to choose the lag. So far is different from the time series. Like the time series we have the lag acceleration, guide us the lag length. Either it's 1 lag or 2 lag or 3 lags, right? For example, like in the time series, right, we have the option, for example, like I just showed you like time series. You also remember the time series we open them as a wow. Then you click OK, right? And here it's just a time series. It's a time series analysis. So for time series, you can go to the wow, right? Then choose the lag structure. It means that under the lag structure, choose the lag length criteria. So based on the, for example, this is time series, then I will choose lag number 3. But it's not for my case, because now I'm dealing with a panel. I cannot use this option. So what you should do for time series, you can, based on my selection criteria is number 3. Why? Because this is based on the pool data. It's based on pool, right? It's based on pool because you see here is depends on 200. Means that it's based on the years here, right? So this number 3 here. So what you should do? So for me, I will check as the one first, right? One first. So you see very seldom people discuss about how many line you want to put inside. But for my case, for how many observation, I only have 20, right? I only have 20 observation and 10 years. So I will start to test for the line one first one. Okay. So I go to view here. Go to option, right? Yeah. Go to quick and then go to that. Just now the base my face already. Johansson qualification. So I click OK. So like the option just now, I go to the feature and then ask us to choose the line, right? I will start with the one first, right? One. So it's will invoke a lot of freedom, right? Because it's the line classification for the different angle genus. So once you click OK, then you can see here, as you observe in your workdown, sample 35 to 54, and 11, and that include observation is 200. 200 observation. This is for the panel. Johansson-Fisher panel configuration test is a panel analysis. So what is the difference compared to the time series framework? So you can not only see the panel configuration statistic, you also can see the cross-section, right? Cross-section statistic for the zero vectors. It means that for this most one also for each cross-section, 10 cross-section. Why? Because this Mandala and Wu is use the Fisher framework on the Johansson p-value, right? They use that framework to recalculate the based on the Fisher approach on the Johansson this Johansson p-value. So to come up to give their own Fisher statistic, which is this one from the trace test. So from here, right, based on the p-value, and then they form the test statistic together with the p-value. So the p-value here shows that 43.45, right, together with the p-value, and then compare with this, and also this Fisher statistic from the max hygiene statistic. So also these two also shows a significant at 1%. So this is based on the, so what is the conclusion? We only have one co-integrating factors. Only one, right? Yeah, only one. So you can conclude that only one, right? Only one means that reject the noun of no conjugation, and you got the conclusion is only one conjugating factors. Only one conjugating factors. So how about the individual? Individual, if you want to look at the individual, right? So here for how many out of this 10, if you test for one conjugated versus two conjugated vectors, so here got 1, 2, 3, 4, 5. 5 out of 10. 5 out of 10 that reject the no conjugation, right? This is for the one vector at most, it means that for 0, at most 1, and at most 2. So at most 2 is none of them significant. At most 1 is only 1, but it's still 10%. But when you're testing no conjugating, it means that no conjugation for this one, only 5 out of 10. There is one conjugating factor. But in the general it shows that based on this Fisher statistic, so your conclusion is you only have one conjugating factor for all your cross section. Only one. So now that is what we say the Johansson's Fisher pattern conjugation test. But the widely used is the Petroni as compared to the Cow and Johansson. Okay. So now let's go through your e-views. So besides this one, so as you observe, the journal article I shared just now also got the panel causality. Am I right? So now once you found that your variable is I0, right? So what you should do, for example, I1 should do. So once you found out that your variable is I1, then got you need to do for this causality, you can test it, right? So let's see, you go to view, and then click on the Granger causality. So there are two type of the panel causality here. One is the stack test, and it's based on the common coefficient. The other one is proposed by these two measures, pooling. Yeah, it's based on individual coefficient. So nowadays, mostly people use this one because it's based on individual coefficient as compared to the common coefficient. So by default, I plan to include these two, whereas I start at one first. So I click OK. So this is a pairwise Granger causality. So again, this one is do not account the integrated property of the series. So this one, if you found I not, we can proceed right with this one. So since I think what is my conclusion already for the CAP and also IMP method. So before we want to, this is in the level, right? If let's say the CAP, IMP, and BAL are I1, and then now I found conjugation, I cannot use this level. I need to make it in the first difference changes to test for Granger causality. So the result here is not valid. If my, I think my result also shows that CAP is I1, right? Let me check. Unit root test. Oh, sorry. Unit root test, right? That's my conclusion already, I forget already. Yeah, I1 right. Let me double confirm. First difference. Yeah. CAP I1. How about IMP? I made also I1. How about BAL? Oh, these two. Okay. So in this case, right, let me double check. Okay. Okay, based on Hartley test is I1 now. So okay, so I can make a conclusion. Maybe it's a general is I1. So since this CAP, IMB, and also BAL are I1, so I can say that the result for my Granger causality actually is not valid, right? Because I'm not first difference of variables, right? So what I should do? You have to first difference it, right? So how to first difference it? So you first difference the series and then you rerun the regression. You rerun the regression, see whether it's workable or not. So you rerun it with the first difference. This, you first difference your series. Okay, so you first difference your series, then your result will change, right? So you can compare because this one is you have an I1 variable, so you have to first difference it only test for the causality test, or you can proceed with the panel VCM to test for the Granger causality also can. That is the idea why we cannot proceed with the level to test for Granger causality because of the I1 series. Level is not able to solve the spurious regression. Okay, so that's the thing. Yeah. So there is another panel conjugation test, right, which is based on this second one. So second option, you click OK. So that is this is a newly cannot say new lah. It's quite recent, widely used by recent journal articles, because this one is based on the individual coefficient. So there is a homogeneous cost against alternative Brandon causality as a rationale. So again, you have the first difference of variable before you run the analysis, and then the result quite different, right, as compared to the common coefficient, because only one Brandon costs the CAP. INV Brandon costs the CAP. Only one significant, but not for others hypothesis, only one. So how to look at the hypothesis is a rationale. These are the rationale, and I can say that all the rationale here not able to reject the rationale, right? All the statistics here not able to reject the rationale except the last one. So investment is Brandon cost the CAP, but no for others variables. Only investment go to the CAP. So this is a Panel configuration test, a Panel causality test based on the DH. This is a DH Panel causality test. Okay? Have you tried? For first difference, right, just put the D, right? D in the front and then put a parenthesis. So okay, so now you finish the analysis part. So if you go through the journal article I shared, I think there are several interesting papers you can refer, right? For example, like the paper, this paper, Albergis, right? Yeah, Albergis I showed just now. Yeah, this one. For this panel configuration test, right? So you can see, you can separate into different panels and to study the causality. This Albergis. And then this another paper is talking about just now to show you just now, and then they proceed from the time series and then move to the panel together with the threshold unit. This is another advanced and then fully modified as well. So they can report the fully modified for each country, fully modified. So now what I want to share with you is another interesting paper which going to little bit touch on our next week discussion. Is this one, right? Published in 2021. You can refer to this paper. It's the relationship between the tourism and economic growth for the BRICS country. So a panel correlation analysis. So this paper is a bit really related to what we studied. So we start with the, I think we're going to discuss on this panel ARDL next week, right? Panel ARDL next week. So we're going to talk on this Pullman group, and then and also the panel Brandon causality. This one, right? The DH. Yeah, DH. So you can refer the details discussion on the DH, right? So instead of the pool causality, so like the common coefficient is like what we did just now, the panel configuration test. For the first option is a panel the pool causality. So the difference between the DH and the pool. So DH is based on the individual goal statistic, right? It's different. So you can see you can see the discussion here, what's different between the DH and also the pool causality. So and this is the panel ARDL approach. I mean the panel ARDL models, like panel ARDL model is similar like the time series ARDL. Just this one is extend to in the panel setting. So instead of single country, now we can extend to become in a panel settings, multiple country or multiple firms. So this is a panel ECN models. So we can study the long run as well as the short run based on this panel ECN. This is a panel error correction models. So error correction models you can see the short run impact on the dependence variable, which is the economic growth, right? So where's the EG here? Let me see the EG. Where's the EG? There's EG. EG is economic growth, right? Yeah. So the variable here is including the GDP, and then it's used to proxy for the EG. EG is economic growth. So the variable is changes in the log for the EG. Log for the EG here. So you can see this. They're going to do the bound test to test for the integration for this error correction models. And so like the paper here, right? They will start with the discrete statistic. They will describe the variable, right? So like you did for group assignment, you can describe the variable first. And then when you describe, right, either you want to log the variable or you use the level form. So remember, for all the macro variable, we have to log the variable, natural logarithm for the variables. Why? In order to reduce the skew of the variables, especially you deal with the billions series. So you can see here the mean for the variable is quite small, right, as compared to that's why they want to log the variable because like 7.9, because for FT, right, it's quite high value. So you try to log the variable so you obtain to minimize the skew. So they will start with the panel linear test, right, by using the LLC and IPS. And then level first difference is how they are report the result. So don't just copy and paste the EView output in your report, So you have to report the result like this, Report the result like this. Don't just copy and then paste the EView output or screenshot the EView output. So this we are training you to report the result, right? So this is the way we report. Then you report the variables, and then you use the appropriate ID to log the variable, or you use the level. You use the level variables. Then after that, you also need to describe your tables, right? Don't just let the table like that. You have to describe the table. Actually, what is your result, right? What is your result, and then what is the stationarity result? So this paper actually is very good, right, for you to follow. So you can report the result like this, and then to tell us whether you have the I1 or I0 series. Then this paper then proceed to the panel ARDL, which we're going to discuss next week, panel ARDL. And then configuration, they found the conclusion is configuration. Then not only that, they also shows the long run estimate as well as the short run estimate together with the ECT terms. This is a Pullman group panel ARDL approach. So there is a motivation behind why we want to use the panel ARDL instead of the Petroni or the Johansson-Fisher configuration test. Because of the I1, I0 issue like the time series, so panel ARDL is just an extension idea behind the time series ARDL. So there is why they come up with these papers. So not only that, the paper also proceed to use that the DH, like what you test just now, to test for the panel causality. So now they just based on the level, right? So is it appropriate or not? So based on the level, but they found that all there are bi-directional between the variables. So FT cos EG, EG cos FT, very fixed relationship. Something like that. So this is the paper here. Then another paper is talking about this one. Public debt and economic growth. I said discuss this paper already. Let me see. So this paper we got lower income, middle income, upper middle income. So you can divide the sample, or maybe in so many countries, right? You can group into two also can. Right? You can before that you can run some preliminary tests, for example, the unit test, CD test, CIPS test, to check the properties of the series. Then after that, once you found out that there is a I1, then you can proceed to the, like for example, like the co-integration test. Like the Petroni, and this paper also use the Westerlund. You can actually discover yourself what is Westerlund, right? So it's not discussed in the class, but it's another type of panel co-integration. It's called Westerlund co-integration paper, 2007. Then discuss the bit. Then in your group assignment, right, actually you need to discuss also what approach you are using, right? Not just copy paste the previous output and then summarize the result. You have to let us know actually what approach you are using. So what approach you have to describe, for example, like the panel configuration test. We are not expect you to show all the test statistic, right? And you can just describe like this. You can say Petroni proposed 7 statistic, and then it's time to go back home. It's a between and then between, something like that, right? Yeah, I think that's this we're going to discuss next week. And another one is asymmetric area. You also can proceed to the asymmetry as well. Yeah, so if you want to do, for example, for your another project or etc., you can proceed with asymmetric area, but we just stop here only to just touch on the grouping group. Yeah, actually the idea is asymmetry have their own motivation. Why want to use the asymmetry and then with the panel area format. So and then the result you can see how they report the result with the panel unit test with this IPS, LLC and CIPS. And we cover all the tests here already, right? We cover the test and then the model with the constant and the model with the constant and train. Right? And then for all the variables and also test in the first difference and also the level. So level, first difference. So this is how they summarize the result. Then for the panel quantification test, we hint also this is between two. This is between the we hint and something wrong. Even though published already also this one. So you have a group, you have a group test statistic, then you report whether you have quantification or not. Then also for the Western and also ARCR approach. So this will be discussed next week. Okay, you have to go back home. Going to the brain already. So any questions so far? So this is a short discussion. Next week we're going to have another short discussion. So the first event for me is celebrate your result that we need at the evening. Okay. So we're going to grab the championship. Then we will have a short meeting.